This is lesson 1.6, solving compound inequalities. We're going to get to absolute value in the next video. But let's just first define compound inequality. It's two inequalities joined by the word and or the word or. So conjunction is a compound statement that uses the word and. So in a conjunction, it's true if and only if both inequalities are true. So that and is like they're going to be conjoined, conjunction. So they're together. I almost kind of think of it like a dumbbell, even though those are teeny tiny little weights there. But it's connected. So here's an example of two individual ones, and then it put together to be a compound inequality, more than one part, two parts there with an and. So this and this. So this intersection is a solution of sets of two inequalities. The conjunctions can be written in a single statement too. Here they're written as two separate, but they would just be connected like this to be written as a single statement versus two separate, as seen above. So let's go ahead and solve an and compound inequality. So here it is written as the conjunction all together, single statement. And we have two methods. The first method is where we solve them separately, kind of pull them apart. So if we kind of cover up this right-hand side here, we can see that 10 is less than or equal to 3y minus 2. So that's my inequality here. And then cover up the left-hand part, and we get 3y minus 2 is less than 19. Here that is in green. So then we would just go ahead and finish solving those just like we would. So first step, add 2 to both sides, bring down what's left. Last step there, divide by 3. So 4 is less than or equal to y. Or if you wanted to write it with the variable first, put the variable, switch the sign, and that's equivalent. So either one of those would be correct. And then over here we would solve this one. Oops, don't need that. Plus 2 on both sides. So 3y is less than 21. And divide by 3. So y is less than 7. The other method is to solve both together. And that would be to first add 2. Now whatever we do, we have to do to both sides there. So it's kind of like we've got two equations being solved at the same time. And then we have a 3y, excuse the email. And then we have 21. And last step, divide by 3. We have to do it on every side. So now we get 4 less than or equal to y less than 7. And that's the same answer. It's just written in that single statement form. So if we were to graph that, we would have 4, and then 5, 6, 7. And since there is a line underneath the one with the 4, we're going to have a solid dot and an open circle in the 7 since there's no or equal to. And we have y is greater than 4, so greater than 4, but less than 7. So that's, again, our and is going to be that dumbbell look. So just filled in between the two. And that would be our graph. So let's take a look at the next example. Another and. If you want to pause and do this one on your own, you are more than welcome to do that. Or you can continue along with me if you need to. Undo the half either by dividing by a half or multiplying by its reciprocal. So times it by 2. That gets rid of that half. X is greater than or equal to negative 4. Over here, subtract 1. So we're solving the two separate inequalities. And then divide by 2. And we would get 0. So to graph that, we would make our number line here. So 0, negative 1, negative 2, negative 3, negative 4. Close circle at negative 4, open circle at 0, and we are and, but we can always go ahead and double check, x is greater than negative 4, yep, so go bigger, but less than 0, so it's that dumbbell look with the and. And there we go. All right. let's talk about disjunct, a compound statement that uses the word or. So those are going opposite directions. So this one or this one. In a disjunction, it is true if and only if one or more of the inequalities is true. So here is an example. We could have this one or this one, and there they are put together going opposites with the or. A union is a solution set of two inequalities. And we'll talk about or next, looking at our example. Solve and graph on a number line. So our number line's below. So we have our or, we're just solving each of them. So subtract 3, and then we'll graph them on the same number line. Divide by -1. Uh-oh, what happens when we divide by a negative? Our sign switches. Don't forget that rule. Very important. So now we can go ahead and graph this. So -1, 0, 1, 2, 3, 4. And we're going to have a closed circle at 4 and an open circle at -1. And we are x is less than -1, and we're or, so we know they're going to go opposite directions, but it's always good to double check to make sure that they do. So you can pause the video and then move on to your next example, actually your last example for the video, and then check your answer whenever you are ready. So to check, subtract 3 from both sides. X is less than or equal to -1. Over here, divide by 3. So x is greater than 3. So graphing, -1, 0, 1, 2, 3. Open circle at 3. Closed circle at -1, because we have the line underneath there, it could be equal to. And we are going less than -1, greater than 3, and it's an or. They're going opposite directions.